Hello, welcome back to the channel. So in this video I'll be looking at the 2019 1.3 paper 1 question for maths. I hope Barnaba Mr. of electricity don't want to take electricity before we finish this question. So let's just try. Sorry. So we have what we are required to consider the product 1 times 2 times 3 times 4 all the way up to 30, and then we are required to determine the largest value of k such that 3 exponent k is a factor of this product. Okay, interesting. Yeah, so let's just be clear with one another what a product is and what a factor is before we start lying to each other. We have a factor, we have a product. Okay, I'll just give you a couple of examples. With a product, 3 times 2 equals to 6. So we are saying 6 is a product of 2 and 3. 2 and 3 in that order, because you multiply 2 and 3 together to get 6. So this whole expression, it's a product because all the values in the product, you can multiply them together to give you a certain value. We're not even going to try to do that, because if we try to estimate what the value is, it's just a big number in this case. So worry not about that. Just know a product, it just means you multiply values together to get a certain value, and then that's basically what by a product they mean. They just mean multiplication of certain numbers together to get a certain number. That's basically a product. With regards to, or do I move there? You can have 1 times 2 times 3 times 4. This whole thing is a product as well. A product of what? Of 1, 2, 3, and 4. You can also have 1 times 2 times 3. That's a whole product as well. A product of 1, 2, and 3. Basically, that's it. So, assuming you are getting bored by this thing of a product and whatnot, I believe you already know what a product is. So, now that you know what a product is, let's look at a fact. For instance, this product of 1, 2, 3, and 4, it has factors. Whatever the product is, let's maybe try to see if we can get the value of that. Or let me start with a simpler thing. This product that we had. This is basically 6. You see, what are the factors of 6? The factors of 6, it's actually the very same values which give you the product. 1, 2, and 3, those are factors of 6. If we are to look for factors of 6 which are in the form of 3 exponent, let's say k, like they did there, but the whole thing is a factor, why would that be? How would that 3 exponent k be a factor? If k is actually equals to 1, that's basically the same as just having 3. So how it ends up being a factor is that now 3 cancels the 3, then you're just left with that, which is a whole number. What whole number do we have? It's just 2, because 1 times 2 is just 2. So basically, for 3 exponent k to be a factor, it must be such that when you say 3 exponent k, that 3 exponent k, if you were to simplify it, and maybe you also try to simplify the numerator, you can have that denominator cancelling some values of the numerator there, or being cancelled basically, so that whatever answer you end up having here is just a multiplication of the terms that you already had in the product, you see, because that 2 is basically just a multiplication of the terms that you already had in the product. That's basically how you conclude that 3 exponent k is actually a factor of the product that you had. I hope that is clear. Assuming that is clear, now let's look at this question that we are given. I really hope what I just said is clear. If it's not clear, please ask, and then we shall try to clarify, or maybe try to rewind or pause a bit and play back what I've just said. Try to make sense out of that. Hope there is sense in that, because I'm really confident in that. So suppose now we have 3 exponent k. Okay, so 3 exponent k is a factor of this whole product. Like I said, if it's going to be a factor of this product, whatever value you substitute for k, we must be able to ultimately cancel the values, or the denominator. The denominator must be able to cancel with some of the values in the product. Suppose k is actually 1. What happens? Then you know what happens is this. This is basically just 3. It will cancel with that 3. Again, suppose this k is it's what? Is 2. What's happening? 3 exponent 2, what's that? That's like you can rewrite it as 3 times 3, because 3 exponent 2 is just basically 3 times 3. When k is 2, basically you're just saying in the denominator you have something like this. So in that case, what's happening? This 3 will cancel with that 3, maybe. But remember, there's other values here, other multiples of 3. Like even 30 is a multiple of 3, and it can be written as 3 times what? 30 can be written as what? Let me try to find out with its prime factors. Rather, it can be written as 3 times 2 times 5. That is exact 30. So it will mean that the 3 in the 30 will cancel this 3, you see, and then you are left with those being in the place of 30, that 3 and 5 being in the place of 30. And then that means when you have cancelled the denominator completely, whatever you are left with, this answer that you're going to have here is just the multiplication of the terms in the numerator. That's how you conclude that this 3 exponent k being equals to 2, it's still a factor of this product, because you are so sure that the answer that you're going to have when you divide the product by 3 exponent 2, it's actually a whole number. It doesn't have a remainder. I hope that makes sense. So if that makes sense, think of this. Keep increasing the value of k, because they're asking for the largest value of k. Just keep increasing the value of k and see how far, or the largest value can get to. At this point, it might not be clear. You might think, hey, I'm asking for a lot. But actually, here's what's happening. This value of k, it can start from k equals to 1 to a certain value. There's a limit to which you can go to, as long as you remain within this product. And how you determine that limit, you must realize that 3 exponent 1, 3 exponent 2, 3 exponent 3, I'm basically, because 3 exponent, this is like 3, this is 9, this is 27. It's basically the multiples of, what is it? 3, 9, and 27. These are some multiples of 3. 30 cannot be written as 3 exponent something, but it actually has a 3 in it when you try to write it with its prime factors. So instead of just only checking those values in the product, which can be written as 3 exponent a certain number from 1 to whatever that highest value we're trying to do, you can also check just basically look at all the multiples of 3 from 3 until 30, because they all have 3 in them. So why are we so interested in the ones that have a 3 in them, or they can be written with the prime factor of 3? It's because we are so sure that when we write those values with a prime factor of 3, whatever we'll have in the denominator, it will be able to cancel with that value. I don't know if that makes that much sense. It actually doesn't, to some extent. Because the whole idea, okay, let me just write it, and then maybe if I explain what I've written, it will be much more easy. So you can look at all the multiples of 3, 6, 9, 12, 15, 18, 21, 24, 27, and 30. All these values, they are part of the product that we are looking at, and all these values, they can be written in terms of 3. 3 is basically just 3. 6, it's you can write it as what is it, let's say that's like 2 times 3. 9 can be written in terms of 3 as 3 squared. 12 is like 3 times 4. 15 is like 3 times what? Times 5. And then 18, it can be written as how can we write 18 in terms of 3? We can, let me just figure that out. It's basically 2 times 3 squared, because 3 squared is like 9. Yeah, 2 times 9, it's 18. So with 21, we can write it as 3 times 7. With 24, we can write it as 2 exponent 3 times 3, something of that nature. And then 27, remember that question that we did previously. And then 30, 30, I think I've just given you the value for 30, how we can write it as 2 times 3 times 5. So I hope you see that, all that. You're probably still wondering, where am I taking you? Okay, let me try to see if I can clarify that. So basically, all those values of k that will make the denominator, which is 3 exponent k, a factor of the product. You can think of whatever value you can think of from 1, keep going up. You would realize that the highest value of k you can achieve for 3 exponent k, for which this 3 exponent k is still going to remain a factor of the product. It's basically given by the addition of the, what is it, this exponents of 3. This first one, which is 1, and here you have 1 again. Let me just do it like this. 1 plus 1 plus 2 plus 1 here, this 2 there, plus 1 here, plus this 2, plus 1 here, plus 1 here, plus 3, plus 1 there. The total, how much is it? This is 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 there. The total is actually 14. Why am I writing 4? So the largest value of k, it's actually 14. I'm just gonna try to maybe make it make sense as to why it's 14. So look, all those values in the product, 1, 2, 3, 4, all the way to 30, you can try to write them as maybe with in terms of 3. Only the ones which are multiples of 3, they'll have, it's possible to write them in terms of 3. As for the others that come in between, like 1, 2, 4, 5, those ones you really can't write them in terms of 3. So just forget about that. The only ones that can be written in terms of 3 is these ones which are multiples of 3. Once you have done that, you would realize that all this, like in this product, when you have all the values maybe written, all the values which are multiples of 3 written with their prime factors like this, maybe you can call them prime factors or in terms of 3 like that, whichever English you prefer, it's fine. So suppose you have written them in that format. This one, you write it as in terms of 3 like that. There's 5, there's 6, you write it as 6, you're gonna write it as 3 times 2. That 30, you're gonna write it as that. So all the terms you might write them such as that. And then in the denominator, you're still having your 3 exponent k like that. So you start with like we did initially. You start with what you call k equals to 1. You keep increasing that k to 14. You start with k equals to 1, and then you see if when you substitute k equals to 1, you've already established before that this is going to cancel that. It doesn't have to be this 3 that you cancel. It could be any of the 3s that you think of. But ultimately, what will make the denominator a factor of the product is the fact that the answer that you're going to get here, once you've decided on whatever value you put between 1 and 14 for k, it's still just the answer which is achieved by the product, or what is it, the multiplication of the terms in the numerator, which therefore guarantees you that the product divided by k to whatever, 3 to whatever k you've decided to be between 1 and 14. Hey, I lost my thought process there. But basically, I hope you get where I was going with this whole thing. What between 1 and 14, the ultimate thing is that you are still going to be left with just the answer which does not have a remainder, or the remainder is 0. Because the only time you're going to have a remainder, it's in a case whereby, or you stand the chance of having a remainder, it's in a case whereby maybe you cancel the 3 exponent whatever. Remember this 3 exponent, let's say if it's 3 exponent 3, you can write it as 3 times 3 times 3, and then you keep cancelling this 3 with that, this 3 with maybe the 3 that is in the 6, the other 3 will be cancelled by 3 that's probably here, which is the one in the 30, and then that leaves you with the denominator being just nothing, or just 1, and then the numerator therefore just gives you multiply all the terms, and then you get the value there, and then voila, you are so sure now because you are able to cancel all the values in the denominator, or all the 3's in the denominator, if I can put it like that, and then you get a value which doesn't have which is just basically a multiplication of the remaining values in the product, and then that's it. I don't know if I just complicated this question further than it was supposed to be, or I made it any simpler, but I hope I tried to make sense, and then it became a bit simpler, because I've seen some shorter videos where I was like, for me myself, I understand, but I wonder if the student will understand what they just did. But yeah, that's basically how they arrived at 14 here. Thank you for watching. See you in another video. Already see what we're going to be doing in another video. The 2020, and then ultimately 2020.